Hey guys, um, I'm back. We're gonna do lesson 15.2 today. First I want to say I really miss you guys. I know this is getting really tough and just hang in there, keep pushing. You can do this. We don't have a whole lot left. Um, and I'm here for you when you need me. So today we're going to continue our unit on factoring. So last week we were learning about greatest common factor, GCF. And so now I'm going to give you a different technique for factoring polynomials that look a little bit different than what we did last week. So before we do that, I'm going to have you start with a warm-up. And so with this warm-up, this is a multiplication problem. So we're going to distribute. We did this in a lesson a couple weeks ago. We're going to multiply this thing all out. So that would give me x times x, so that's x squared. X times 5 is 5x. And then you remember you multiply on the inside as well. So you'd have 2 times x is 2x. And 2 times 5 gives you 10. And so if we clean this up and do our combining like terms step, we would have x squared plus 7x plus 10. Okay, so what we're going to be doing today is kind of the opposite of what we just did. So I'm going to kind of draw a little line here. So when you start with something like x plus 2 times x plus 5, and you get an answer like we have, that was by multiplying, right? Well, factoring is going to be undoing all the work we just did. So like going in reverse. So with factoring, you're going to start with something that looks like this answer, which is a trinomial, by the way, because it's got 3 terms. And you're going to figure out how to go backwards and turn it back into 2 binomials that are multiplied together. So going from 2 binomials down to here is multiplication, and then going in reverse is factoring. Now it may seem like it's going to be really tough to go in reverse and figure out what the multiplication or what your 2 binomials are going to look like, but there are little tricks and patterns to it that I'm going to walk you through. Okay, so what we're going to do is we're going to make this more like general. So instead of having numbers like 7x and 10 like we had here, we're going to call them letters. That way I can give you like a general description of what's going on. So it says here to factor a trinomial of the form x squared plus bx plus c, which b and c just mean like some number. You must find 2 numbers that, and then we're going to fill this in, and I'm going to show you what I mean as well, but you're going to find 2 numbers that multiply to c, which remember c is just that 3rd number in your trinomial. So we need 2 numbers that multiply and equal this c value. And we also want these 2 numbers to add up to b. And b is that middle value in front of the x. So it's like a puzzle, okay, guys? So your goal is you've got this trinomial that has 3 terms, right? You want to figure out the answer to the puzzle by figuring out what numbers multiply and equal the 3rd value, but also add up to the middle value. And I'll show you what I mean here. Let me fix this real quick. Okay, so there we go. So in our trinomial that we're factoring, this middle value would be called the b value, which I don't really call it b value very often. I usually just call it the middle value. And this value at the end would be called the c value, if you follow that like general formula that was up at the beginning of this slide. Our job is to figure out how to factor it. And so real quick, I'm going to go back. Factoring means you're starting with a trinomial and you're going back to 2 binomials multiplied together. okay? And so I'll walk you through the steps, and don't worry, we're going to do lots of examples. So basically, I want to make it look like this. I want to have two parentheses, two sets of parentheses. I want to figure out like what times what equals this whole thing, okay? So maybe we'll start at the beginning and we'll say the beginning is x squared. So that means that x times x would be needed because x times x is x squared. Then we're going to figure out what number times what number equals 12, okay? So the first thing you think of, I don't know, 6 and 2. Anybody else think of 6 and 2? So 6 times 2 equals 12. So I'm going to put a plus 6 and a plus 2 because 6 times 2 equals 12. All right, now bear with me. If you're writing notes right now, that's awesome, but don't write what I'm about to write because I actually did the problem wrong, and I'm going to show you why, so don't write this down. Okay, just watch. Now, if I multiply this back out, it should give me what I've got up here in the problem. Okay, that's the theory. We just don't know if it's going to work. So we're going to stop. We're going to multiply it out, and we're going to see if it gives me what I have up here. Okay, that's the goal. So if I multiply this out, I get x squared plus 2x plus 6x plus 12. Okay, so let's analyze like what's good and what's bad about what we have here. Well, we do have x squared, and that is one thing we need. Awesome. We do have 12 at the end, and that is something else we need. Awesome. But what we did wrong is something in the middle, because the middle term that we get is 8x, but we want it to be 7x. That just means that the combination of 6 and 2 is not correct because the 6 and the 2 gave us 8 in the middle, and we want 7 in the middle, okay? So we're going to go back, and we're going to try something different. Remember, these are like puzzles, okay? So you're not going to always get it right the first time. Sometimes you have to do, you know, a guess and check, like try something. If that doesn't work, try something else, okay? Now, I know there's got to be another way because we just started with, you know, what times what equals 12, and we said 6 and 2, but there are other things that multiply to equal 12, right? So let's try something else. So there's 1 and 12, or there's 3 and 4. So let's try 3 and 4. Okay, I'm going to do the check again real quick. So I'm going to multiply back through. X times x would be x squared. X times 4 would be 4x. 3 times x would be 3x, and then 3 times 4 would be 12. And let me keep going and do my like terms also. Those look like they're going to add up to 7x. Look at this. We got it right this time. So the 3 and the 4 worked, okay? Here's why. Here's the important thing. 3 and 4 worked for two reasons. One, because 3 times 4 is 12. But reason number two, because 3 plus 4 is 7. Okay, so here's the pattern. You want to multiply to equal your third number. 3 times 4 equals 12. But you want those numbers to add up to the middle number of 7. Okay, I have another trick that I learned actually on Delta Math. I can't remember what they call it, the X method or X puzzle, something like that. But basically you make a big X, you put a times sign and a plus sign. My plus sign kind of looks like a times sign. Hold on. You put a times sign and a plus sign. That's a little better. And then you fill in, what do you want the numbers to multiply to? I want them to multiply to the 12. It's always multiply to the third number. And I want them to add up to the middle number, which is a 7, okay? And so you have to pick two numbers that fit in this puzzle. Two numbers that multiply to 12 but add to 7. So look, 3 times 4 is 12, and 3 plus 4 is 7. You see what's happening here? 3 plus 4 is 7, but 3 times 4 is 12. It's like a little chart to help you organize your thoughts. So maybe we'll try that little chart on a couple more examples here. Oh, look, we already did that one. So we'll just say see previous slide. Okay, so let's go to this next one with 20, 9, or n squared plus 9n plus 20. Okay, here's what I can do without a whole lot of work. Is I could start with, I need n squared, so I would have n times n. And then I'm going to do my little X puzzle to figure out what the numbers are going to be. Okay, remember, it's a pattern, and it's always like this. Are you listening? It's always like this. Always multiply to the third number, which in this case is 20, the C value. Always have it add up to the middle term, which is 9. Okay, so we got to figure out what two numbers multiply to 20, but also add up to 9. So what multiplies to 20? 2 and 10. But I can't use 2 and 10 because do 2 plus 10 equal 9? No, they don't. So 2 and 10 are not going to work. What else multiplies to 20? 5 and 4? Well, 5 and 4 work. 5 times 4 is 20, but 5 plus 4 is 9, so that does work. Okay? Here's the thing. Because I told you the pattern and the trick, you don't have to sit there and multiply all this out again. If you know that the two numbers multiply to 20 and add up to 9, like the question says, you can stop there. You don't need to check your answer every single time, okay? You're just learning a new pattern. So if you can show me that they add up to 9 and multiply to 20, you're good. Let's do another. So I h squared plus 9h plus 18. So let's get it set up. To parentheses. H squared means I need an h times an h. And then I'm going to make my little x chart. Oh, whoops, that's not right. Times goes up the top. Times plus. All right, I want it to times to 18 and add to 9. So, what times what equals 18? 1 and 18. 1 and 18. Is 1 and 18 going to work? No, because 1 plus 18 is not 9. It's 19. So get that out of there. What else equals 18 when you multiply? What, 2 and 9? Is 2 and 9 going to work? No, because 2 plus 9 is 11, so that's not going to work either. I think we only have one more choice. What, 6 times 3? 6 times 3 is 18, and 6 plus 3 is 9. So we've got a winner. So I need 6 and 3. By the way, you could put 3 and then 6. The order does not matter at all. Okay, you just need a 6 and a 3. All right, let's do one more on this page, and then we'll go to a new video to do the next set of examples. So, I don't know, maybe this one. So, k squared plus 6k plus 5. So, I need to set it up with k times k to get k squared. And then I'm going to make my x times and plus. And I want it to times to the third number, which is 5, and add up to the middle, which is a 6. So what times what equals 5? I can only think of one thing. 1 and 5. And that's going to work because 1 times 5 is 5, like we just said. But 1 plus 5 does add up to 6. So you have a winner. 1 and 5.